Welcome to class 0416. Here are some problems. Google form, chop chop. I guess if you're watching the recording, that's utterly useless. Never mind. If you're watching the recording, you do not need to Google form. Everybody else Google form. Uh, uh, B, there are multiple ways to write it. Hey, could I get you all to make it easier for me to grade? Solve for C. In question B, solve for capacitance. Make it easy for me to see that you got it right. Olivia, we're not doing E yet. I've got lots of things. We're gonna do a little, talk a little, do a little, talk a little. Just do A through D now. And I'm gonna call that times up now. Wait, I haven't looked at the last one. Okay. Okay, crap. Well, that's not good. Great on the first three. Last one, you guys need to be able to at least find this in your notes, eh? When I say natural frequency, what letter am I asking about? Omega, not W, omega, yes, not F. If I said state the equation for frequency of a pendulum, what would I be asking for? What letter would am I asking if I don't say natural? That's F. Just frequency, F. Natural frequency, angular velocity, omega. Okay. Well, here, I'll answer all of them. Here we go. All of them. Ohm's law, ver. You know what? If we're writing this down in our notes, I would give credit. I gave full credit for V equals I times R. But if I'm going to state it down and you're putting this in your notes and you're thinking about it, let me emphasize, V is not the voltage at a thing. V is a change in voltage from one place to another along a resistor. So the change in voltage across a resistor is the current through the resistor times the resistance of the resistor. Delta V equals IR. Solving for capacitance, charge per volt. V equals F lambda. You can rearrange these algebraically. I just wanted you to solve for Q equals C times V is not wrong. Half you told me Q equals C times V. Great, I'm glad you remembered. I just wanted to have them uniform so I could grade quickly. V equals delta, V equals IR. Capacitance equals charge per volt. Wave speed equals frequency times wavelength. And natural frequency of a pendulum is square root gravitational field divided by pendulum length. Yeah, totally. I mean, it's hard to type lambda. Yeah, I don't care that you could type the letter. And I would not test you on the name of the letter either. Okay, is good? Write these down. If you don't have them, write these down. I'm going to ask you to reason about them in half a second. In 2 shakes of a lamb's tail, as my father would have said. 1 over 2 pi times that. Ellen, which? What? Yes, the length of the pendulum, the distance from the pivot point to the bob. Hi, Bob. Is good? Any questions about what any of these mean? Great. Let's actually reason now. We'll start with just the resistor. Just a resistor. Resistor, hardly know her. There we go. EF. Tell me EF. For all of these, unless I specifically say, in meters per second or whatever, if I'm asking about by what ratio, by what factor, how does something change, give me a number. Make it easy for me to grade. If something doubles, tell me 2. If something triples, tell me 3. If something does not change, tell me 1. Yeah? You guys comfortable with does not change means ratio 1? Yeah? Okay. Please, I've got a number of people telling me HALVES, DOUBLES. It will make my life happier if you write a number. To double is to have a factor of 2. To quarter is to have a factor of 1/4. If it does not change, the ratio is 1. By what factor? By what factor does R change? By what factor does V change? Hey, yeah? Okay, 2 minutes to think about these 2 problems. Your best shot. Hey, give me your best shot. 3, 2, 1, hit enter. Got a lot of empty space. And I'm really glad we're doing this because there are 63 wrong answers so far out of 66 people, 63 wrong answers. That's for 63 people times 2 responses. So half, we're at half. Some of you are getting both right. A lot of you are getting both wrong. Most people are getting half right. I would like better than that. You guys have seen these questions both on previous exams. We've talked through the answers. We've talked through this in class. This is a theme that we keep coming back to. Let's reflect on these and learn from this and meditate upon this. Yes, it's been a minute, but my goal here is to have you have a mental picture of these things and be able to see through my clever tricks. Please, for the love of God, please, 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 please meditate upon the answers that I'm about to give you. Reflect on them. Make them part of you. Don't memorize them. Both answers does not change. 1. Both of these ask you to reason about the formula voltage drop equals current times resistance. Let's talk about this. If V changes, the left side of my equation changes. The right side of my equation must also be twice as great. But why are you assuming the R is the one that changes? Why doesn't I change? Which changes? How do you know? If this were an algebra class, you wouldn't. You'd be stuck. The answer would be cannot be determined without more information given. This is not algebra. This is physics. This is physics! Just like in the movie. That was too long ago. Oh, you got me? Okay, you get it. Good. Okay, you get a 300% on your exam. There we go. Just kidding. Okay. V equals I times R, which changes which is the theme of this half of lecture today. What's a resistor? A resistor's a straw. What's a voltage? It's how hard you suck. I mean, sorry, how much pressure your mouth applies to the straw. What is I? How fast the double caramel macchiato flows into your mouth. I'm coffee addict. What can I say? Let me ask you this. A straw is filling my thirsty mouth at a given rate when I apply a given amount of mouth suction. If I apply twice as much mouth suction, how does the straw change? Does the straw itself reshape itself to become easier or harder to flow through? No, no, no. What happens? I get more or less flow. You may now write this down as something to meditate upon in your daily physics trance. The resistance of a resistor is not controlled by electricity. The resistance of a resistor controls electricity. The resistance of a resistor is controlled by properties of the resistor. Again, what I would encourage you to write is something to the effect of, the resistance of a resistor is not controlled by electricity. The resistance of the resistor controls electricity. The resistance of the resistor is controlled by the properties of the resistor. For question F, you're assuming that I get the same amount pushed through. How do you know that the amount pushed through is what changes instead of the voltage? You're asking about F, yeah? What do you know about batteries? What's the basic function of a battery? Keeps the voltage constant. So this is not about a resistance keeping its resistance, a resistor keeping its resistance constant. I've got two different resistors, a resistor, a different resistor with a different resistance. This is a batteries question. You're absolutely right. If I knew that the fluid flow rate was the same, I must have applied a different pressure to the cocktail stirrer compared to the boba straw. Okay. Leads on to the next thing. Question F is, I apply mouth suction to a boba straw, then I drink through a cocktail stirrer. How does the mouth pressure change? You have to reason about this, not based on V equals I times R. Well, R is going up, so V is going up. You have to reason based on what is driving this current. What do you know about batteries? What do you know about changing resistors and having a battery? The different resistors have a different resistance. Yes, that's true. Does a battery keep a constant V and let I change? Does a battery keep a constant I and let V change? Methinks I buy a 9-volt battery, not a 100 milliamp battery, right? A 9-volt tells me the voltage of the 9-volt, and that's 9 volts, more or less, whether or not I'm using it, whether it's plugged in or not, whether it's turned on or not. It's a 9-volt battery, it stays 9 volts. Now, there is such thing as voltage sag that we haven't talked about, internal resistance. But for the most part, a 9-volt battery provides 9 volts of voltage, right? Doesn't change the kind of battery just because you connect it to something and turn up the juice or not. What's happening is you're getting more or less current. Deja vu with all this. I could neither confirm nor deny that I am just going to copy these questions and put them on the final exam. I can neither confirm nor deny allegations. Hint, hint, please think about this. No, I probably wouldn't actually. I probably wouldn't exactly copy it. I'd change it slightly because I don't want memorization to be how to pass my class. I want thinking to be how to pass my class. Okay, that said. I said that said. Do two more. G and H. I will warn you that 80% of my 3 o'clock section missed H. Please use the equations, use your knowledge, use caution. And let me remind y'all, C does not stand for charge. Very good question. Hold on, wait 1 hot second. Very good question. Before we move on, wait. I'm going to hide this. I don't want you to do this. I want you to think about this question. Aren't the components in V equals IR proportional to each other? Yes! They absolutely are. Voltage is proportional to current. Voltage is proportional to resistance. Absolutely. But that doesn't mean that when you change resistance, that changes voltage. Maybe it changes current. Resistance can be, you could solve the equation for resistance, say resistance equals voltage divided by current. Then resistance is inversely proportional to current and directly proportional to voltage. You have an equation relating 3 variables. If I tell you how one of them changes, you cannot immediately say that, aha, this other one has to change in this way. You have to think about, well, hold on, what's the physics of the situation? Does this affect this or does this affect that? That's the moral of the story. That's the theme I am playing on my flute for you all. How does this affect that? Well, there might be a mathematical direct proportional relationship, but that doesn't mean that A controls B. The resistance of a resistor, what's controlled by? He's controlled by the resistor, the length, the area, and the material. Okay, now, GH. Again, I have several people telling me words here. Please, for the sake of making it easier for me to get the quick class response, I want numbers. Tell me a number. For G, I am looking for a numerical factor. If I do not change 1, if I get half as great, 0.5. If I triple, 3. If I increase by a factor of 10, 10. No words. For H, I am looking for a number, a wave speed in meters per second, just a number. Tell me a number. Please do not tell me words. Is good? Carry on. Also, I love you all, even the ones who type words after I said that. Okay, also I have a bunch of people, for H, I've got about 5 people in the room getting this right, and we might have rather more than 5 people getting this, except I'm not asking a ratio this time. Please look, what am I asking? Not what is the ratio, what is the new wave speed in meters per second? If you told me a ratio, you're not answering the question asked. I want number, but not a ratio. I'm looking for a value here. Not by what factor have I changed, but what is my value of V? Okay, one more minute to struggle with these, and I shall reveal all. Oh, y'all could talk to your neighbors, by the way. Actually, you should talk to your neighbors. Once you've done this, or as you're doing it, bouncing ideas off each other, build your brains. I encourage it. There are only like 3 people talking to each other. Okay, I'll take it. G does not change. One. One. What controls capacitors' capacitance? Area, distance, properties of the capacitor. Q equals C times V. C equals Q over V. Sure, great. Capacitance is directly proportional to charge if you know something about the voltage remaining constant. Again, my comparison. You know, my speed is miles divided by hours. Yeah. I'm driving at 60 miles an hour for 4 hours. Oof, long car trip. If I drive for 8 hours, how fast am I going? 60 miles an hour, right? Just because the time doubles doesn't mean that the speed halves, right? If I told you I drive 60 miles an hour for 4 hours, then I drive the same distance in a time of 8 hours. How long did it take? You could say, oh, well, if I drove at half the speed, if I drove twice as long at half the speed, it drove the same distance. God damn it, I said that the wrong way around. You could reason that if I took twice as long and the same distance, the speed is half as much. But just saying I double time, you don't immediately know that you've halved the speed. Okay. For G, if I say a capacitor is connected to a battery, something happens, cough, cough, and the capacitor is holding twice as much charge while still connected to the same battery. I must have changed the capacitor. The plate area doubled, the plate separation halved. In this problem, I doubled the charge on a capacitor. What happened to the capacitor? The capacitor, without any other hint, any other words, any reason to suspect that the voltage has not simply changed. The capacitor's capacitance has not changed. What affects the capacitor? Unless I have some reason to believe that the capacitance of the capacitor might be changeable, Capacitance is normally just fixed by the capacitor. There do exist things called variable capacitors. I have given problems before where I say pull the plates of the capacitor apart while it's still attached to the battery. What happens to the charge, so on and so forth. I'm not saying that the answer, do not memorize capacitance never changes. That's not the conclusion that I want you to take away. I want you to take away, think about what does affect capacitance. Does the problem give me any hint that this, that, or the other is changing? The question H, we're still only at a third of y'all getting this. What controls V? Properties of the string, right? Did I change the string or did I change the oscillation? I changed the oscillation. Does that change the wave speed? No. Wave speed does not change just because I increase the frequency. Y'all should have seen this in your lab experiments. Do you have your data? Take a look at your data. You measured wave speed by multiplying frequency times wavelength. Until you change the string or the tension, what y'all should have just seen in lab is that doubling the frequency halves the wavelength. Tripling the frequency thirds the wavelength. It did not change V. You multiplied it up to the same number again and again and again and again. The only way you changed V was by changing the string. Did I change the string? No. Follow up, what is the wave speed? How do I get the wave speed? V equals F lambda. That's the equation that we had before, right? What's F now? 80. What's lambda now? Not still 50. Actually, for that matter, I don't need to know what F is now. All I need to know is F didn't change. F was 40 when wavelength was half a meter. Bam, 20 meters per second. You don't even need to think about I doubled the frequency. The wave speed didn't change. Therefore, use the time when you knew the frequency and wavelength simultaneously. If you wrote if you wrote 40 meters per second, reflect on this. 40 meters per second is if you know that the wavelength does not change. That's a possible answer to a different problem. If I say I double the frequency and observe the same wavelength, two strings are being shaken, one at 40 cycles per second, one at 80 cycles per second. They both have a 50 centimeter standing wave. What can you deduce? The frequency is different. The wavelength is the same. The V's must be different. They're different strings, but here I didn't change the string. What affects what? What controls what? What is actually changing? Don't just look at an equation and guess which factor changes. Have a reason for them. Okay, I have been playing the same theme again. Please just turn to your neighbor for 30 seconds. What is the theme here? What is the idea? What is Dr. Tucker promising to put a quarter of your final exam questions like? Talk to each other for 2 seconds.
Things about the material. I remember doing that.
Good.
But when we doubled the frequency on the same material, we got half the shorter wavelength.
That's true.
So wavelength at 25 centimeters. Convert that into the new frequency of 80.
What's 80 times 0.25? 80 times 0.25 is not 40. You do 80 times 0.5? Okay, there you go. Give me a question. I am a question vampire and I am going to die unless I get a question. You don't want to kill me, do you? Well, maybe some of you do. Maybe most of you do, but come on, someone keep me alive here. Give me a question. What you thinking? David, what you thinking? The question is, does wave speed being constant apply to all media? Yes. Let me qualify that. Any wave in anything has a frequency wavelength equation where frequency times wavelength multiplies up to the wave speed. The way to change the wave speed is to change the medium in some way. It is not true that all media have the same wave speed. Speed of light, speed of sound, these can change. In air, in glasses material, glasses plastic, and in water, light slows down. Light does not always travel at the same speed. In air, hotter, colder, more humid, less humid, these affect the speed of sound. But for a given medium, you play a trumpet where the temperature in a room where the temperature is one thing, it's going to make one note. You play the same trumpet in a different room where the temperature is different, it's going to make a different frequency because the air, the trumpet, will carry, for the same length of instrument, will carry a different, the same length of resonator will carry a different frequency. So there will always be this trade-off between the wave speed is controlled by the medium. For a given medium, frequency times wavelength, the frequency doesn't control the V, the wavelength doesn't control the V, the frequency controls the wavelength and vice versa. Does that answer your question? I will also admit to you that there are special times when wave speed does affect wave propagation. Rainbows wouldn't exist if it weren't for the fact that red light travels slightly slower than blue light in water. That's not a fundamental wave phenomenon. If you want to understand rainbows, you got to go deeper down into how does light interact with water. There's a more sophisticated second level to this. The foundational idea about waves is that unless something funky is going on, the base behavior is frequency affects wavelength, wavelength affects frequency, neither touch wave speed. Thank you for asking. Other questions? Okay. I would really dearly like to hit on a couple of other things. Just tell me I, real fast. Which has a greater period? A pendulum swinging a big swing, 20 degrees back and forth, a pendulum giving a faint swing, 5 degrees back and forth. You may use the equation that we wrote down before, by the way. Oh, period is 2 pi over omega, by the way, if you wish. Yep. Just which has greater? Which takes longer to go back and forth? A big swing or a little swing? Use the equation, Luke. Kylie, assume the same everything else, just the amplitude of the swing is different. Which takes longer to go back and forth? Or are they the same? Assuming all other things are the same, Alrighty, let's put it to the test. Let us do the experiment. Anyone have a stopwatch handy? Stopwatch app on thy phone? Nerd with a watch? Oh, lots of nerds with watches. Okay, so let's say one tick is complete when it comes back to the furthest from your perspective left extent, yeah? I'll say tick, just in case the people with stopwatch, I don't know. Count, a good way to get a good estimate would be count 5 ticks and divide by 5, yeah? Let's do it. Do this experiment. Here's probably 30-degree swing. Ready? Tick, 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 tick. That was 5, right? 2.1 seconds. Ish per tick. Now let's have a real gentle. Ready? Friction might actually slow us down significantly over this. Let's count 3 and divide by 3, yeah? Tick, tick, tick. Oh, it's the same. What about a really big swing? 3 ticks. Here, ready? Tick, tick, tick. What's that formula involved? What variables appear in that there formula? G and L. What's G? Gravitational field. What's L? Length of the pendulum. Do you see an A there? Is there an angle there? There's no angle there. I mean, my ancestors are from England. There's an angle here, but there's no angle there. A. Amplitude has no effect on frequency. This is why grandfather clocks use pendulums. Pendulums keep the time constant, even though their period gets, even though their amplitude gets smaller and smaller, they keep the ticking a uniform, keep the ticking a uniform pace. What does change the tick frequency? Let's do it. Here, can someone give me a stopwatching again? Ready? 3, 2, 1. Tick, 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 tick. Divide by 4. What was that? Was it 2.1 seconds? No way, Josue. Right? Right? That was more like 1 second. What's the moral of the story? The moral of the story is, one, you're allowed to have a dangly thing on the final exam. You can do the experiment yourself. I won't count you as cheating if you just let something swing back and forth. For that matter, you a dangly thing, just, just, just move your arm, right? I have small oscillations, just letting my arm dangle down there. I have a big oscillation, just letting my arm dangle down there. The bigger the smaller oscillations take the same amount of time. As you get smaller and smaller and smaller, it's the same amount of time. You're going a bigger distance, but you're faster. You're going a smaller distance, but you're slower. Balances out. Or look at the darn equation. There's no A. I don't see an A. Also, I'm stuck. I don't know how to get down. Don't tell double backflip. What? Do I look like someone, Biles? I mean, yes, I know I do, but okay, let's talk about some proportions, some ratios, and some changes. Screw doubling. I'm bored with doubling. I gave doubles to my previous class. There. There. What the hell? Question J if x triples. Question K if x quarters. Question L if x multiplies by 5.1. Can you tell me the ratio of y if I've got a proportional, quadratic, and inverse square equation? I'm not going to tell you what M, A, and C are. The secret. Shh. Can you reason about structure without calculator? I mean, you can still use a calculator, but you can't just plug in numbers here. Also, help me see your answers quickly. I want a single number. Please do not type out TWO. Give me the numeral 2 if you think something doubles, so on and so forth. If something quarters, don't tell me QWARTERS or however the hell you spell it. Tell me 0.25. No words. Oh my God. I love you all, but please, you're killing me, Smalls. M, A, and C are constants now. Yes. Words, words, words. Thank you, you get an F. Just kidding. Or am I? I don't know how, but none of my teachers and professors in college ever said, someday you're going to have a kid like you and you're going to know how it feels. I don't know how. I was never told that. I totally deserved it. And so I won't pass it along, but you know who you are. And I love you all. You're all awesome people. But you are going to math jail, some of you. Oh, broke your brain. No, no, no break brain. You could do it. I will show you how. Okay, it is 5:30. We've only got 15 minutes left in the period. Let's do it. And I apologize if this period is hurting your brain. Hey, oh, that's so much better. I should have done that from the beginning. Okay. I'll probably forget if I said that. God damn it. How can I remember to make that pun for the 3 o'clock? They deserve it. Yes, L says 5.1. Okay, so I am very pleased about J, pretty darn pleased about K, and surprisingly pleased about L. Better than I thought. This is great, but it's not everyone. I'd like this to be everyone. Let's talk about it briefly. One way to do this is what I like to refer to, slightly joking, sort of serious, about is calling experimental arithmetic. The basic idea of experimental arithmetic is if you have something which is pure multiplication, division, square rooting, blah, 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 ratio problems ignore making up BS numbers. Ratio problems ignore BS numbers. This doesn't work if you've got two terms added together. Y equals mx plus b is not a constant ratio mathematics. I'll prove that to you in a second. You'll prove that to you in a second. Y equals m times x. There's no offset. Proportion. We're talking about strict multiplication, division, square roots, blah, 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 blah. You could just take ratios. The constants drop out. So I can make up any number I want. Let's say m is 7 and x is 2. I'm going to make up anything I want. If m is 7 and x is 2, 7 times 2 is 14. If I triple x, I don't drink that. But if I double x, I do drink that. If I triple x, I get 7 times 6 is 42. What is the ratio of 42 to 14? Trace. It doesn't matter the numbers you did either. What if I let m be, oh, how about 1? 2 triples, it becomes 6. 1 times 2 is, grab my calculator there, 2 to 6 triples. It doesn't matter that I chose 2 and 6 either. If m is 3 and x starts at 5, and then triples to become 15. What's 3 times 5? Well, 15. What's 3 times 15? 45. What's the ratio? Ratio is 3. It doesn't matter the numbers you do, as long as the formula only involves multiplication, division, and powers. Then you could throw away those constants, let them be anything you want. The ratio is tripling. Oh, baby, a triple. Is that a song? That sounds like a song. I choose A to be 1. I quarter X. Well, I need an initial value I need an initial value for X. Let's start out with A equals 1 and X equals 1. 1 times 1 squared. Ooh, tough one. If I quarter X, what do I get? What's 1/4 squared? I'm picking the easiest possible numbers. Oh, hey, look. 1 turns into 1/16. What's my ratio? Not 16. If the ratio is 16, the output is 16 times larger than it was. 1/16 is the correct answer. Y equals constant over x squared. Now let me forget the forget the experimental sorry. Forget the experimental arithmetic method. Let's do a simple ratio of two terms. I'm going to have y2 over y1. By what factor does y change if I plug in y2 over y1? All right, c over x2, c squared, c over x1 squared. C is the same. Cancel, cancel. What do I get when I have 1 over x2 squared divided by 1 over x1 squared? What happens when I've got a what happens when I've got a fraction and a fraction? Yeah, the downstairs fraction flips. The upstairs denominator stays in the denominator. The downstairs denominator, double denominators, goes upstairs. Yeah? Deja vu? Okay. So if I say, if I have multiplied x by 5.1, x2 is 5.1 times as great as x1. 26.1-ish, 5.1 squared, oh, something like that. 1/26.1, or approximately 0.038. Or if you just wrote 1 over 5.1 squared, I give that credit too. Okay, notice what's the common theme. If I just have a multiplier of, first one, a multiplier of tripling, x triples, multiplier of 3, how is x acting in this equation? It is linear, it is proportional. Y is directly proportional to x, x to the first power. If I take 3 to the first power, I get my answer, 3. Second one, x is to the second power. If my change, my ratio is x is quartering, I plug in the ratio, the factor of x into the squaring operation. 1/4 squared is 1/16. So x is to the negative second power. If I just plug in the how does x change, 5.1 to the negative second power is bang, 0.038. In every case, you don't have to have the numbers. If they make you feel better, you can make up numbers, but you don't have to have numbers. You certainly don't have to be given numbers to get from the get-go. If you've got a structure of an equation, you could reason about how does this affect that? By what ratio do things change? Turn to your neighbor and express any of these ways. I just told you 3 different paths to getting these answers. Experimental arithmetic, algebra, or plug in factor into where x goes and reason. Turn to your neighbor and express one of those ways in your own words. All right, so any questions before I go on to the very last few minutes? I do want to make a point before I let you go. I want to make lots of points, but I will make one more point before I let you go. Almost all the equations that I've taught you involve multiplication, division, an occasional square, an occasional square root here or there. That's not, are we out? I thought I had till 45. 2 more minutes. It is not a universal law that you could plug in numbers and take a ratio and be done. Plug in numbers. Screw it. We're not doing n. Just do this. I wanted you to reason about how do square roots affect things, but no. Just one more thing. One more thing. By what factor does y change when I triple x? There's question M. By what factor does y change if I triple x? Chop, chop, quick like a bunny. Not much time left. Are you done yet? By what factor does y change if I triple x? Okay, last chance. I'd really like every single person to put a response here, eh? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Blast off? Correct, Parley! Yay! The correct answer is insufficient information. Atham, there is no definitive answer. Jeffrey, well, it does change, but Andres, I don't know. Yes! This is not a proportion. Look, when x equals 1, what's 2 times 1 plus 5? When x triples, what do I get? So is the ratio 11 to 7? What is 11 sevenths, by the way? 1.35? Whatever. 1.4, 1.5, who gives a crap? Now let's plug in 2 times 50 plus 5. What's 2 times 50? 105. Now I triple 50. What's that become? 305? What's the ratio? Well, look, you don't need to grab your calculator. 305 105ths is about 3. It's not the same ratio. This isn't a problem that just involves multiplying, dividing, an occasional square root or exponent here. I got two different terms. One of them is changing, the other isn't. They're added together. This isn't a proportionality. So most of the physics laws we deal with have a direct, inverse, proportional, square, blah, 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 blah. It's not a universal law. You can't always do this with everything. Take the ratio of two numbers and assume it's constant. We'll pick this up on Monday. Go, adios, physics.